too, in nature, and biologists will explain better than I can. I'm not a biologist, but you know, if when an organism wants to reproduce, like a fish might produce thousands or hundreds of thousands of eggs, right? Knowing most of them are not going to emit, so it's kind of that's called our selective strategy. So like lots and lots and lots of seeds, hoping that just a few of them will sprout. And some of our efforts have been sort of like that, just kind of getting information out there. Others are what are called case selective, like what we do with our children. We raise very few children and put a whole lot of resources into raising one child for a long time. And so we've been doing some of that too. And sometimes we transition from, you know, once you do that big scatter, you find out, okay, this is different, this is different. So we're not saying, oh, we want to move into Mexico, we want to move into this, we wait to see what's working. Because one thing we've discovered is that we don't promote biomimicry. We don't try and convince people of biomimicry. There's so many people that once they learn about it, oh my gosh, this is what we need to do. And then when that energy builds, we respond to that.
What's the sort of relationship to more communities or smaller community groups, maybe even close to your home or I mean, there's the sort of design and high-tech part of it, and the children part, but is there a sort of more community part to this?
Again, that's sort of in a responsive mode. There are some local groups that have, because we're local, we'll put resources into something that's, you know, not going to affect things globally, but we've been doing work with some local organizations around Montana. Like I'm giving a workshop in Yellowstone Park at the end of June, and there's a group called Pioneers in the United States, and there's a central group there, and there's different cities that have a little local component to it, and we get involved with that. And it was a youth festival last week that we were involved with. So again, it's more like when we see an opportunity and someone asks, then we.
There seems to be a relationship between biomimicry and complex system theory, like a natural relationship. Do you guys work with like the Santa Fe Institute or institutions that work the same efforts for climate theory?
We do. We don't. The course that one Jorge are taking is a 2-year certificate course. It's kind of our equivalent to a master's degree, and through that we'll be working with various institutes to learn things like systems theory. Because you're right on. It's very integral part. And then there's people who are doing research, that we work with colleagues that are doing research on that, and then we learn from them. You're getting into the really hard part of biomimicry there. System thinking, ecosystem level stuff. It's much harder to get your head around that, but it's very, very important.
As much as biomimicry is emulating nature, I'm curious to know about what is the stand of biomimicry on genetical modification on certain animals and plants, and if will be a product in the future, will this be looked into biomimicry as part to be emulated in the future?
When we do biomimicry, I told you all kinds of bio-inspired stuff, and the genetic engineering is that you're talking about falls in some of that same bioengineering sort of camp, and that's not part of biomimicry. We are emulating the strategies of nature. We're not manipulating nature. We're not using nature. If something isn't going to happen naturally, we don't force it to happen. You know, it's not natural to have a strawberry gene in a fish or a fish gene in a horn. Well, that's what's done, you know. And there's different kinds of working with nature that are more and less sustainable. They're also not biomimicry. Sustainable harvesting, for example, that's using nature. It's not biomimicry. It could be very sustainable, but that's not biomimicry. And it's like genetic engineering is again using nature And it might even represent some of those principles that you see, but it's fundamentally not emulating the strategies of nature, it's manipulating nature. So that's not, genetic engineering isn't, we can't say blanket that we're against genetic engineering, but it is not part of the world of biomimicry. And that's why that word emulation is so important, because we're taking strategies from nature. How does nature accomplish this function? And how can we emulate that? Not how can we manipulate nature to accomplish what we want.
Do you have any more examples of buildings designing by this way?
I do have a few more. There's more and more out there. It's fun to search the literature. There's a lot of the biomimicry examples are sort of embedded inside a design, so you don't see them. They're harder to see. And some of them are more biomorphic. It's copying the shapes from nature. But things like the ventilation systems, solar energy, reusing water, all those kind of things are biomimetic, and they're being incorporated more and more into buildings, which you would say, oh, this is biomimicry, but it's incorporating other components of biomimicry. Because as you know, as architects, a building has to accomplish many, many, many different functions, and so each of those can be biomimetic. But we do have more. We need to get them up on our website.
Is there an example here in Mexico?
I think there is a bank in Mexico. Not really. But again, when you look at a building, it's not sometimes the whole building can be a beautiful expression of many, biomimetic strategies, but it's the individual strategies that normally we see. So I don't know if there's a shining example in Mexico of incorporating all those different things. But when you have solar, when you've got water collection and recycling, you've got gray water systems, those are all being more biomimetic.
Biomimicry is about design and technology, but about the philosophy and how we touch society to back where we belong, that is nature, and how can make all the people think about.
How can we do that? Well, we always have to tell people to go outside. And a lot of the things we do in our workshop help you look at nature differently, recognize your role in nature, learn to observe again, learn to feel. Your body is part of nature. We forget that we are nature. We're natural organisms. We have all this crazy technology around us, but we're an organism just like the water bear. We're just one of many. And so it's hard for people like you who live in a big urban environment to be a part of nature. But you could reach it in smaller ways too, like when you just have a plant, you can look at a bird, you can start looking at, why does it do that? And just we found a dead dragonfly today, and you can spend hours looking at that. And so you do have it around you, but you have to try a little harder because you can't immerse yourself in it as easily here. But it's very important to be in nature and reorient your thinking about your role in nature. And that is a really, really important part of it, and it's a practice that you have to develop over time.
Hello. What is how can biomimicry be applied to the individual?
The individual?
Yes, to one person, to you.
Well, I think what the theme was getting at, that your view of your role in nature, and it's the humbling of yourself.
And what I meant is like the process of the human, of us, like not the water bear, but what we do by naturally. How can this be applied to the thinking, I guess?
Well, what do you think?
I don't know.
Anyone else want to? What can we learn? Can you give an example of what functions that are performed in our bodies that maybe are performed in a building?
corrupting.
Articulations.
Articulations?
Yes.
Like,
Yeah, like movements. Like the wrist. Some people are trying to build stuff that can actually move, like buildings and stuff that can actually move. So it works better.
and things like,
Yeah, there is an example with, when you get a cut, how the blood is, well, the plates are clogging that, and that has been applied also to pipeline, for example.
Well, we filter water, control temperatures.
I'm sorry, can you repeat that?
We filter water,
We filter water.
control the temperature.
Control temperature. So we have lots of sensors built into it to respond, just like we need the, buildings to respond to the environment. You can learn an infinite amount from your own body. I had one guy, I asked people, in fact, any of you coming tomorrow, you're supposed to bring a natural artifact. Remember that? And the more interesting, the better. But one guy, he was kind of resistant to biomimicry anyhow, and he was a professor, and he said, I brought my body. Oh, good. But I said, that's actually an excellent. We have so many things going on in our human body, from the molecular scale up to the larger scale, how we interact.
The information processor we have in our brain, no computer can relate to that. I mean, that's a bigger challenge to how we process information in the cell.
And it's one thing that's really, it's an interesting question, because one fun thing to do, you can look at all of biology to find a good example of some function we want to accomplish. Another, you can turn that around and look at one organism and just say, how much can I learn from one organism? And it can be something unlikely, like a dead dragonfly, or a moth, or a single leaf even. And all the functions that are being performed in that one organism, and then how that relates to the design that you're trying to do.
Could you please elaborate on the ways that you're looking at biomimicry in the design of companies or organizations? You have a slide there, but that's sort of fast.
Yeah, and that one is looking at how information feeds. One example, and there can be many different models. So the one example I showed there is talking about in a rainforest how water and nutrients and information feeds up and down through the different strata in a rainforest, and how that same sort of concept can apply to a company, and how the dynamic response is all going on. And so a lot of the information that's really important is that the bottom level that moves up. And in companies, we tend to have command and control, one person, then another set of people, and then they make decisions for this person. It's very much top-down, and sort of top-down pyramid fashion. We don't allow a whole lot to come up from the bottom. But in nature, we have a lot more interdependent, interconnected, and some parts are real important at one time, and they're less important at other times. It's that diversity and decentralized. And so there's different, when you look at your company, depending on the nature of your company, you can look at the different information flows, decision flows, and then say, well, what am I really doing here? What kind of relationships do I have? And then look to nature for models of that. And also on a kind of an ecosystem level, many companies operate on sort of a predator-prey relationship or with the world around them, or in a parasitic sort of a way. And once you analyze, well, how am I relating to my, the system around me, is that really the most beneficial way? And you could say, well, how does nature really have that relationship? And you could say, well, maybe we want mutualism. Maybe there's other kinds of models out there for relationships. Maybe that's a better model for us. How does that work? How can we apply that? So again, there's no right answer. There's many different ways. It's like many different ways that nature designed for leaves to accomplish the same basic function. And so there can be different models out there. So you can analyze your current system against nature, and then you can also look at models from nature and so.
Is that an internal project from the Biomimicry Institute?
No, we don't. The Guild will help companies, either company structure, but more often designing a system or a product, work through that. The Guild itself does not do design work, and the Institute itself does not generate design work. We generate, knowledge, resources, and tools, and that sort of thing. So we, on our end, but the Guild can help a company figure out. But of course, you know your own company best, so we help you with the process.
How much does the biomimicry method rely on technology?
I guess not at all. It's a method, it's a process that you go through. So you don't need it, and it's applied differently depending on what you're designing. And the biomimicry method does not necessarily replace your existing design method. It can inform the method, and sometimes at each node around the spiral, you go off and do more traditional design and go back into it. I guess I'm not sure. I didn't talk about the design method very much. Are you going to be here tomorrow?
No, I did the last year workshop.
Oh, okay.
Yeah, but like how much technological knowledge do you need to take a nature's process into 1 year?
When you do biomimicry, if you're a designer of some sort, you have to have a biologist help you. Because you can go around the design spiral with the methodology by yourself for a while, because we all know some biology. But then once you get down into really how is nature doing that, then you have to ask someone who has more knowledge about that. And it really helps to have a biologist who at the beginning even ask the right questions, and maybe form your design question a little differently. So it's very interdisciplinary, which makes it really fun. You get the crossing of different knowledge bases, and it helps when more people have more knowledge of biomimicry. You can call it an expert from outside, to inform you. But it's nice when you already know what you're doing with it. So you don't need any more technological knowledge than you would to do your design anyhow, except to know the methodology. Does that answer your question? I'm not sure.
Yeah, well, it was more like a practical question. When you are already doing the emulation, how will you, or how much technology do you need to, for example, the bionic car, right? How much technology did they need in order to achieve that car?
Well, in that case, the first part of it, they simply looked at the shape of the fish and emulated that shape, and they adjusted it, and then so that's their standard technology they have in their design process. Anyhow, the fish gives them the starting point, and then in the case of the internal structure, they created new software to help them create structure based on where force would apply. So that required new technology in that case, which the technology was based on the process that how skeleton was built. So you have to have biological knowledge and then be able to translate that, and that's what you learn when you learn about biomimicry methods.
Yes, I have a question. Many of the most interesting or amazing applications of biomimicry have taken several years to develop, many times 3, 4, 5 years or longer, and involve hundreds of thousands or even millions of in investments. So it's mostly researchers at universities that do these things. But what are some of the areas where, more ordinary people, let's say, can have quick wins or low-hanging fruit, let's say?
Yeah. That's a good question, because, and I don't work with the Guild, but when they go into a company, usually it's a few people who are really excited about biomimicry. The rest of the company hasn't heard of it, doesn't care. And so having a few small wins at the beginning to show that it's successful is good. And a quick win would be to simply take an existing biomimetic technology and substitute. Like there's a paint that's based on that lotus leaf structure, lotus-on paint, and switch out your paint, existing paint for that paint, and then, track the benefits of that. So simple substitution is really easy. So, existing technology, and then you can do just the idea would be to do like in nature, doesn't completely replace things very often. So, incremental changes are not always. Sometimes catastrophic changes require allow an opportunity for new things to come in. But yeah, just trying to find small wins, looking at existing technologies, small changes that don't require huge investment. But biomimicry is just a tool. It's not a result. And so whatever result you get, you're going to face the very same challenges that any other innovation faces in the marketplace. But presumably you've got the advantage of being innovative and sustainable.
Yes, well, mine is another question. I want to tell you I'm very glad to be here tonight because in opposition to many of the lectures we attended during our course, where they present some sort of knowledge with cases and samples, and we discuss around it. Tonight, what I felt is we've had an invitation to go out, to watch nature, to build together this knowledge and use it in our daily work, our activity, our professional activity. So thank you very much for being here with us.
I appreciate it. Exactly what you're
In your personal opinion, why human nature got to learn from his environment? Because right now we have to change the way we think, but we already did it in a bad way. So why this happened? We know the facts, we know the revolution, Industrial Revolution, we know everything, but why is human nature?
That's a really fascinating question. And that's another reason why biomimicry needs to be interdisciplinary. You need to get social scientists, historians, and anthropologists, archaeologists involved to find out where did these different, how did mankind go off on this path? And people, I don't have a quick answer for that. But some discussions have been around things like as soon as we figured out fire, then we needed fuel. And suddenly fire gave us all this choice and empowered us to do all kinds of things. And that's one theory, that's the starting point. And some people would argue that, use the word bad, like how did we start going on this bad path? But really, just like all other organisms, we're opportunistic. Every organism would take advantage of whatever's available. And if you learn how to do something that's to your advantage, either as an individual or as your species, of course you're going to go that direction. And we have this amazing brain relative to other creatures, and that's been a huge advantage. So we've used our brain to help us gather more resources, our population has exploded, it's been, to be more comfortable, to live longer. So it's a natural thing, the way our technologies are essentially natural because we invented them and we use resources that are here on Earth. Now, we're growing like weeds. We're acting like weeds on Earth. You can take a land that's been disturbed and weeds grow in, and they consume everything really fast. And we don't like weeds in our gardens, but in the ecosystem, weeds are the first things to help take disturbed land and get growth going again. And so there's a benefit to weeds, and eventually other things take over. So right now, we're acting like weeds. We're just consuming resources and keep looking for more places, and our capitalist system is the same way. We need new markets all the time. And so maybe we need to think, gosh, not worry so much about where we went wrong, but where we need to go in the next phase. And we're sort of at the end of this weed phase, and we need to go into a more mature ecosystem sort of relationships with the earth and with each other. Because we could debate that endlessly, discuss that endlessly. And it's a good question, but in some ways I think it's more healthy just to look about what relationships should we be having, and how can we take all of our technology and knowledge and ability to learn new things and apply that into a new kind of world view.
How long do you think it's going to take for the whole world to understand all this?
it's exploding, and we realize it's really interesting to me that I don't read a lot of popular magazines, but I was in the airport and I was scanning the architecture, the building-based magazines, and one of them I picked up, of course, all was green, which you see more and more of, but the whole issue was green, and there was biomimicry in it. Like, wow, this is something that we didn't generate, that people are finding it, and it's being propagated in the popular press. And so we feel it's expanding rapidly. It's a completely different thing to start to incorporate it, into our designs and into our worldview, but it's coming. I'm very, very hopeful. I mean, that's what I love. It's so hopeful.
I'm just curious about the example that was shown in the book regarding agriculture to emulate the natural environment. That was in fact in the 90s, so I was wondering if you have been successful or if have been reproduced somewhere else.
And just kind of before answering that question, just to make it clear, the Institute does not do research, so we're not, doing this sort of thing. But we're not working, we haven't spent a lot of energy in that area. That's an interesting question that came up recently, and so there are people working in that area. And the same people, the Urban Planning Institute and the permaculture people, and that's sort of expanding too. But we haven't put a whole lot of emphasis on that. Any other questions?
I would like to say, before I thank Denise for this very inspiring keynote speech, that the Department of Architecture is very much in tune with biomimicry. We think it's a very important subject, and we have incorporated it into our compulsory subjects in the environmental design cycle. Well, thanks to Raúl de Villafranca, who has been our teacher in it. And yes, I would love to. Biologists to the design table for us, here in the Department of Architecture, in the undergraduate course, and also in the diploma course, and we are thinking of doing the same in the graduate program that we have now, which of course Jose Luis has now said that we will probably look for organizing another graduate course. The other thing is that he also has organized not a composite but an elective course, which is based entirely on biomimicry. So we're on the way of anybody wanting to know that information. I think people were interested in knowing this. And we have teachers, the full-time teachers that are taking the course, the workshop with Denise, starting tomorrow, and we had some teachers as well taking it last year, and we hope to keep on having this workshop year after year. And thank you very much, Denise, for this most inspiring speech. Thank you. Thank you very much.